Have you ever really stopped to think about what's happening behind the scenes when you click on a link? It feels like magic, but it's not. Today, we're going to pull back the curtain on how your data gets from point A to point B. And to do that, we're going to imagine the entire internet as something we can all understand, a giant, super efficient moving company.
Seriously, think about it. You click a link and a website that's physically hosted on a server thousands of miles away just appears instantly. How does that even work? How does the internet know where to send your request? And just as importantly, how to get the exact right information back to your screen and not your neighbor's?
You see, at its heart, the internet is all about solving one massive delivery problem. It's got to figure out how to get huge amounts of digital information from one computer to another, and it has to be reliable and lightning fast. So let's stop thinking about it as magic and start thinking about it as a really, really impressive logistics challenge.
To make this whole thing click, we're going to use this moving company analogy. All your digital life, every website you visit, every email you send, every video you stream, that's your stuff. Your computer, that's your current house. And the server you're trying to reach, well, that's the new house on the other side of the country. Pretty simple, right?
Okay, so if we're going to run a successful moving company, we're going to need a few things. We'll need roads to drive on, a truck to carry the stuff, and of course some boxes to pack everything in. So let's meet the digital versions of these key players.
First up, the roads. This is just your network connection. It could be the Wi-Fi signal in your home, that physical Ethernet cable plugged into your laptop, or even the 5G connection on your phone. These are literally just the roads and highways our data is going to travel on. Next, every moving company needs a truck. And in our digital world, that truck is the Internet Protocol, or IP. The IP's job is simple but crucial. It does all the heavy lifting. It's what carries your data from a source IP address, that's your house, to a destination IP address, the new house.
Now, you wouldn't just throw all your fragile glassware into the back of a moving truck, would you? Of course not. You'd pack it all up carefully. In the digital world, our moving boxes are protocols called TCP and UDP. Every piece of data from an application gets packed neatly into one of these boxes before it even gets near the IP truck.
And this is where it gets really cool, because you actually have a choice of what kind of moving box you want to use. And that choice makes a huge difference. It's kind of like choosing between a super careful white-glove delivery service or a blazingly fast courier that just drops the package and goes. Let's check out the difference.
So the big trade-off here is really about one thing: reliability versus speed. On the left, you've got TCP. TCP is obsessed with getting every single piece of data to its destination perfectly. It establishes a connection, it waits for confirmation that each box arrived, and if one gets lost, hey, no problem, it just sends a new one. Now UDP on the right, it's all about pure, unadulterated speed. It just chucks the boxes onto the truck and sends them off. It's a fire and forget kind of deal, which makes it super fast, but a little less reliable.
So when would you actually use one or the other? Well, think about it. For something like loading a web page or sending an email, every single bit of data is absolutely critical, right? You can't have missing letters or messed up images. That's a job for TCP, our white glove service. But what about a video call or online gaming? Speed is everything there. If you lose a tiny packet of data, it might just cause a tiny, unnoticeable blip on the screen. For that, you want the fast drop-and-go service, UDP.
Okay, so our IP truck has successfully navigated the highways and arrived at the right house, the correct IP address. But our job's not quite done. A server isn't just a simple house. It's more like a giant apartment building with tons of different applications running at the same time. We have to get our boxes to the right apartment.
And this is where port numbers come into play. Just think of them as labels on your moving boxes. Kitchen, bedroom, living room. When a packet of data arrives at the computer, it looks at the port number on the box. That number tells it exactly which application is supposed to get this specific delivery. The web server, the email client, the game, whatever it is.
And there are a lot of rooms available. For both TCP and UDP, there are over 65,000 ports. This massive number of ports is what allows a single computer, a single server, to have thousands of different conversations going on at the exact same time without ever getting the messages mixed up. Now, these ports are kind of split into two main groups. The first 1,000 or so are like the main public-facing rooms in the building. The lobby, the mailroom. These are the well-known permanent ports for common services, like port 80, which is famously for web servers. The rest of the ports, though, are temporary. They're ephemeral. Your computer just grabs one of these for a single conversation, kind of like a temporary visitor's pass that's only good for one visit.
And here is a super important detail to remember.
The set of TCP ports is completely separate from the set of UDP ports. So TCP port 80, the web server's room, is a totally different place than UDP port 80. You can think of them as being in two completely different buildings that just happen to have rooms with the same numbers.
All right, let's put this all together now. We've got our moving truck, our specially chosen boxes, and our room labels. Let's follow a single request for a web page all the way from your browser to a server and all the way back again.
So here's the entire round trip. First, your computer, the client, grabs a temporary port, that visitor's pass we talked about, let's say port 3000. It packs its request into a TCP box and sends it to the server's public front door, port 80. When the server gets it, it sees that room 80 label and knows exactly where it goes. Then, to send the web page back to you, it just swaps the addresses. It sends the data from its port 80, specifically back to your computer's port 3000. And that, right there, is the secret sauce. That's how the internet makes sure the web page you asked for gets back to your browser and not somebody else's.
You know, this whole system of addresses and ports, as simple as it sounds, is what allows the entire global internet to work. It's this elegant but incredibly powerful process that lets any two devices on the whole planet have a direct, organized conversation with each other. It's amazing.
So, our digital moving company did its job perfectly. The truck delivered the right box to the right room in the right building. But that just leads to the next question, doesn't it? Once you open the box, what's actually inside? What language is that data speaking? Well, that's the next layer of the internet, and a story for another time.